Welcome back to another episode of FLEETtv, because science is everywhere. I'm your host, Ashanti Davis, Exhibition Manager with the Fleet Science Center. In this episode, we're gonna get physics-all. This episode is all about physics. You can leave your exercise equipment where it is, and I got you covered for leggings and leg warmers. Sending you out now live to our Fleetster in the field, Ariana, as she gives you the lowdown on Newton's very first law of motion, inertia.
Hi, my name is Ariana, and I've got an idea for some awesome science that you can try at home right now. I'm here at my home to talk to you about Newton's first law of motion, the law of inertia. The law of inertia says that an object in motion will stay in motion, and an object at rest will stay at rest. I'm going to start with just one mug, one index card, and one penny. And I want to get the penny into the mug, try to move the card in a way that will get the penny to fall in. Obviously, I can tilt the card. I want to use the science of the law of inertia. So I want to try to move the card flat and see if I can get the penny to fall in anyway. If I move it slow, will it work? Let's see. No? No. I'm going to try moving the card fast. Ooh, the penny fell right in. That was using inertia. When I moved the card slowly the first time, the card and the penny had a buildup of friction that pretty much acted like a grip and held the penny to the spot that it was on the card. When I moved the card fast, it didn't have enough time to build up enough friction to grip that spot. So the penny stayed put and the card moved. Does that sound familiar? So once the card was out of the way, gravity pulled the penny down into the mug. It's kind of like when a cartoon character runs off a cliff and then stays in midair before falling. The penny was the part that was at rest, and therefore it stayed at rest while the card moved. Obviously, you might have these materials in front of you that you can just use to try this out right now, but you might not have these exact materials. So I've got a couple swaps for you. Instead of a mug, you can use a glass, a plastic cup, or a small Tupperware. You could also use a piece of cardstock instead of the card, if you don't just have index cards lying around. If you don't have coins, you could use maybe a metal washer or a game piece like a checker. If you want to level this up, you can try maybe pulling the card even faster. There you go. You could try adding more weight by stacking up coins on top. I'll stop there for now. You can try more. Or if you really want a challenge, you could try the flick. There we go. So I want you to try all of those out, but I just remembered one more way that you can really level this up that I learned back in my days performing our Don't Try This at Home shows at the Fleet. This is the same principle that works for the tablecloth trick. What a nice memory. But really, remember, as far as that trick is concerned, don't try it at home! Seriously, you could hurt someone or yourself. Don't do it. But do try this one at home and let us know if you think of a new variable to try or how many weights that you are able to stack up. Yeah! Thanks for tuning in and have fun trying this at home.
Thanks so much for that awesome demo, Ariana. I don't know about you, but I personally love Newton's first law. Could you imagine if you came home and your furniture was just slipping and sliding all over your living room and you didn't even do anything? It would be terrifying. If you have some great ways that inertia has impacted your life, go ahead and drop us a line on social. We'd love to hear your stories. And now, because where there's science, there should always be laughter. Sending you out to University Heights and our funniest fleets there. Take it away, Raisin.
Hey FLEETtv, I have been spending all day trying to think up some inertia jokes for you guys, and I've been telling them to my roommate, but none of them are gaining any momentum. Hope you're having a great day.
Have you ever wondered how many pirates it would take to sink a ship? Have you ever wondered how many pennies it would take to sink an aluminum boat? You probably haven't, but sending you out to another Fleetster in the field, Kit in Sarah Mesa, as he gives you a lowdown on another physics concept, density. You may just find out that the size of the boat does matter.
This be your captain at the helm, the one and only Captain Kit. We be taken on a voyage with me hearties, the one and only Penny Pirates. And I'm gonna show you a simple experiment that ye can be doing in your own cabin during these rough weathers and times. So, gather around and I be showing you the supplies you be needing for this very simple experiment you can try out. Alright everybody, so now that we got that silliness out of the way, we can go ahead and take a look at all the things that we'll be needing for our experiment today. What you're going to need one large or small sized plastic tub, some water, a piece of aluminum foil. I need about 10 of my friends here, the 10 penny pirates. So what we're going to do, we're going to create a boat out of that piece of aluminum right there, have the 10 penny pirates float inside this tub right here. Okay, so I got my boat. It's all ready to go. As you can see, it's there floating on top of the water. I'm gonna go ahead and put my pirates on here and we'll see if this boat is able to hold up the 10 penny pirates. Go ahead, make your hypothesis right now. I'll give you a second. Do you think that this boat is gonna be able to hold all 10 of my penny pirates, or is it gonna end up at the bottom of the ocean in Davy Jones' locker? Here we go. I'm gonna start putting these pirates on there. And 10. Still afloat, still above the water. So all those penny pirates, they are super happy. So now what I'm gonna do is I'm gonna go ahead and try to sink my boat. So what if we try and make our boat smaller and maybe see if we can't get it to sink that way? So just to give you an idea of how small my boat is now, I think I could probably only do one penny pirate. All these penny pirates, they made their way back to shore okay, so we're just going to use our boat this time. Got my boat right there. Here we go, on the count of 3. 1, 2, 3. And my boat is right there. My second experiment was a success. I was able to make my boat sink. So you saw on my first boat how it was really wide, it took up a lot of space on top of the water. So all that weight was distributed across the entire ship, so all that weight didn't just sink into one spot. But when I folded my boat down into that smaller size, I took all the weight of the aluminum originally and just compacted it into one spot. So it wasn't as dense as my boat before. Since it had a higher density than my boat before, that's why it sank to the bottom. Here's my challenge for all you young aspiring pirates out there. What can we do differently to see how we can make this experiment up? Maybe one challenge you can try to do is see how many of the penny pirates that your boat can support. Maybe we can even change our pirate crew altogether. Maybe you have the dime pirates or the nickel pirates or the quarter pirates. Can you keep your boat afloat with the same amount of different pirates? 10 quarters, 10 nickels, 10 dimes. Or maybe even change the type of boat that you have altogether, or even the solution that it's supposed to float in. Get creative with it and let's see what you got.
Thanks so much for tuning in to another episode of FLEETtv. We hope you loved it. We hope you learned something. Like us on social, share us with your friends, and most importantly, we'll see you next week.